Hello everyone and welcome to the NPTEL course on pharmacognosy and phytochemistry. In this unit, we are studying oleaginous or oil containing drugs exclusively containing lipids such as fixed oils, fats and waxes as well as volatile oil. In the previous session, we have studied the differences between fixed oils, fats, waxes and volatile oil. Through this session, we are going to start with some examples of drugs containing especially fixed oils. Just to start with, how do fixed oils come into nature? Fixed oils are actually reserved molecules and they form storage energy for the plant species as well as for us as well as the animal species. So fixed oils, you will see the predominant source of fixed oils are mostly the seeds. Bearing a few examples, many seed containing drugs are used for the preparation of fixed oils. Most of your cooking oils, say sesame oil, groundnut oil, sunflower oil, majority of them are obtained from seed drugs where they function as a reserve storage for energy. So how are they biosynthesized? Fixed oils, the content can be broadly divided into two parts. The first part, which is the saponifiable matter, something that can be saponified, and the other part, which is a little minor part, is called as unsaponifiable matter. The saponifiable matter is generally made up of triglycerides, that is your fatty acids. Say for example, you might have different fatty acids which are attached to glycerol as we discussed previously. So this 1-glycerol will form ester linkages with fatty acids. Now I am just representing the fatty acids as are, they might be similar, they might be different, they might be saturated or they might be unsaturated. So all in all, these are what the triglycerides look like, and this individual you can just put it as a long chain carbon containing fatty acids. So your free fatty acids, we can call it here, or your triglycerides, they are obtained from a particular pathway called as acetate mevalonate pathway, wherein acetyl CoA condenses, forms malonyl CoA and undergoes a series of steps to form adducts. Now these adducts are generally in form of 2 carbon units, and that is why in nature you will see the most abundant fatty acids are in multiples of 2, say C12, C14, C16, C18, C20 and so on. The reason is their biosynthetic monomer is a C2 and which is later on polymerizes to form a long chain fatty acid through sequential cyclized steps. When you go to unsaponifiable matter, it contains different molecules. So say for example, when you see a cooking oil, it's not colorless. Now fats, ideally if you see triglycerides, by their nature they are colorless. The color is attributed to pigments which are present in it. These pigments can be something like chlorophyll in case of your olive oil, or it can be carotenoids in case of some other oils where your carotenes are major. So if it is chlorophyll, if it is carotenoid, the other unsaponifiable matter contains lipid soluble ingredients. This includes the fat soluble vitamins, the fat soluble sterols. In animals we have cholesterol, in plants you have phytosterols. This include your cetosterol, stigmasterol and other sterol derivatives. Now they have multiple biosynthetic origin. This might include something like your acetate mevalonate pathway, your shikimic acid pathway, or even a simple polyketide folding for your plant pigments as possible. So the saponifiable matter generally comes from acetate mevalonate pathway. The unsaponifiable matter comes from a diverse pathways. Now we will discuss few examples of drug containing fixed oils. In this session we discuss castor oil, sesame oil and coconut oil. Let's start with the castor oil. Now castor oil is something which is abundantly found in India. If you see, you will come regions in Maharashtra, Gujarat or close to Rajasthan, abundantly castor grows in the wild. It's also cultivated particularly in Andhra Pradesh, Gujarat, Karnataka, and if you go to see internationally in Brazil and Romania. So botanically they are seeds, and what you do is you express the oil from the seeds of the plant Ricinus communis, which is a Euphorbiaceae family member. So this Euphorbiaceae family member is initially wild, but now it is cultivated because of the oil that it yields. So this Ricinus communis is a very fast growing, suckering, perennial growing plant with a nice glossy and palm shaped palmate leaves, which has about 5 to 12 deep lobes, and they are slightly serrated, or what you call it as coarsely toothed. Now they bear what is called as a panicle inflorescence, and on top of it you will find capsules, a little spinous capsules. This spinous capsules, once they mature, break or dehiscent, okay, break open, releasing the seeds. So you can see some seeds here, okay. They are nice mottled or what is called as marble finished seeds, and if you specifically see in this region, you see a tiny outgrowth, and that outgrowth is called as caruncle. Castor seeds can easily be identified by the growth of caruncle. Now for the purpose of cultivation, when you are thinking of quality seeds, it is best that you obtain undamaged seeds. The reason for that is, when you are thinking of preparing an oil from castor seed, if any damaged seed is procured in the process, the damaged seeds creates an exposure to air, and this exposure to air creates rancidity, and that is something we don't want in our pharmaceutical grade oil. So when you're thinking of castor oil preparation, the first thing that you should do is you should grade the seeds. Prefer the seeds in which the testa is intact and unbroken. The testa is very thin, papery, but that is required in case if you want a non-rancid oil. So good quality, unbroken, undamaged seeds are taken. Now once the seeds are taken, they are then crushed in a mechanical press which is slightly grooved, and when it is grooved, the testa or the seed coat kind of separates out. This seed coat, being little papery, with a fan or with a gust of air is blown off, and what is left is the inner part, the endosperm part of it. Now this endosperm is pressed. Generally this is done as cold. We don't want harsh conditions. So cold drawn oil is done using a hydraulic press by applying a pressure about 1 to 2 tons per square inch psi, and at that level you will see that 30% of the oil is drawn. Now this is something which is treated as virgin oil or pharmaceutical grade oil or a good quality oil, because if you see it in terms of a free fatty acid content, which also corresponds to the rancidity, this is relatively less and it's considered to be the best one. The next or little lower grades for commercial or non-pharmaceutical applications can also be obtained if you further presses. Take it for example, you can have a hydraulic press, pressure increased now to 3 tons. That will remove additional more 10% oil, or you can even heat it to get more oil. But what happens in the process, that you might get more oil, but you will see more of this free fatty acids. So in the second, when you are using a high pressure, high temperature combination, you might end up with the oil which has about 5% free fatty acids, and that is not desired in pharmaceutical grade, but for commercial application it's fairly good enough. So such oils are taken for commercial purpose. So that is in the last case where you still want to further extract, what is done is the seed meal or the seed cake which is obtained by pressing is then put into solvent organic solvents such as hexane, petroleum ether, and now these solvents are evaporated to get the last part of oil. So on an average the seed contains about 50% oil, and using various processes we could still get almost 80% oil out of it, but the best 30% which initially comes out is generally saved for pharmaceutical purpose. Now one more thing to remember about castor is it contains a compound called as ricin, and this ricin is a biohazard. That means it is poisonous if you consume it, and if you are thinking of using this oil for pharmaceutical grade, it cannot contain ricin, and ricin being a lectin in nature has a protein component and has a carbohydrate component. So what is done is once the oil is obtained, it is heated. You can heat it at about 80 degrees Celsius and the protein gets agglutinated or denatured. The ricin is rendered inactive. One more thing which is rendered inactive is the enzyme called as lipase. Lipases are responsible for hydrolyzing the triglycerides, and these lipases are also intact in the seed. So if you keep the oil as such, they will keep on hydrolyzing the triglycerides, releasing a lot of free fatty acids, and you know free fatty acids cause rancidity. So steaming serves the purpose of agglutinating two proteins. One is lipase, which can cause release of free fatty acid, and next thing is it neutralizes or agglutinates your ricin, which causes poisoning. Now this oil which is left is kept saved. Any solids which are deposited are then filtered, and then you can use the oil for your pharmaceutical grade. Now castor oil, if you go to see in terms of composition, contains one compound, that is ricinolic acid, which makes up about 80 to 85% of the oil. Now ricinolic acid, if you see structurally, is a C18 carboxylic acid. That means it is a stearic acid derivative. Now this stearic acid C18, if you divide it into half, so at C9 and 10 it will have a double bond, okay, which very closely corresponds to your oleic acid, and then at carbon number 12 it has a hydroxy group. Now this hydroxy group gives it one very important property which can be used to check the purity of castor oil. That means you can take this castor oil and you can try to dissolve it in alcohol. It is one of the very few oils which dissolves in alcohol. Your other cooking oils won't dissolve in alcohol. So you can easily come to know whether it's adulterated or not. In a similar manner, you will see that 5 ml of this castor oil can dissolve in about 10 ml of your petroleum ether. So it has both lipophilic as well as polar solubility in your alcohol. Apart from that, other components which are also obtained from castor are your heptaldehyde. Then you have a C11 compound, that is undecanoic acid. Then similar to your sebum, there is a C10 diacid, which is your sebaceous acid, which is also there in your skin creams nowadays, and definitely ricinolic acid. Now this castor meal has also been used for obtaining enzymes. You know, in your biotechnology you require enzymes, and your castor seeds are interesting source of that. So you can purify your lipases, maltases and even invertases from your castor seeds. It contains an alkaloid, a small content of ricinin, a toxic component ricin, phytins, and the total oil content, as I said, is almost 50% of the seed. So it ranges between 36 to 60%. The castor oil is almost colorless to pale yellow depending upon the grades, with a characteristic, acrid taste and odor, and it's soluble right from alcohol to chloroform, ether, pet ether, but it's insoluble in paraffin or what you can say mineral oil. Going by the standards, it is a oil which is lighter than water with a weight per ml 0.9%. Then refractive index 1.46 to 47, a saponification value of about 177 to 187, which is reasonably good, and because of the hydroxy group it has an acetyl value of about 143 and hydroxyl value of 150. Now these are some things which are being used to determine the constants, determine the value or determine the assay of it. Castor oil has numerous applications. It is given as laxative. You will see a lot of elderly people taking arund oil as a laxative ingredient. So it helps in constipation. The oil is used in preparation of soaps, paints, enamels, varnishes, greases, polishes. But because of its abundance in India, you can see, very well it's taken. So, and you will find it in hydraulics and brake spirits with little modifications obviously, and this modifications can be, if you need to solidify the oil, you hydrogenate it. So, in some cases you use what is called as hydrogenated castor oil, which has a consistency of your vegetable ghee or dalda, whereas in some cases you make it more polar. You can make it more polar by inducing hydroxy groups. So, you have polyhydroxy castor oil, which is a polar derivative of castor oil, and that has also been used in automobile industry. Now coming to fatty acids, if you see ricinoleic acid, it's used in contraceptive creams for its spermicidal activities. You can even break the acid into heptaldehyde. You can get undecanoic acid and sebacic acids, which are the fatty acids present in castor oil, and you can purify it for applications in chemistry as well as in cosmetics. It's an interesting product if you want to get foams, particularly your trolley wheels. If you see those nylon leaven or urethanes, or even in rigid or semi-rigid foams, your castor oil is being used as a plasticizing agent. Now it's also used as lubricant for its good property that it doesn't freeze even at sub-zero temperatures. So it's an excellent lubricant. Now going to your next oil, we have your sesame oil. Now everybody must have been familiar with the image here. This is til ka laddu, and sesame oil is nothing but til oil. Now the significance of til for us is, this is one of the oil which has been prescribed in Ayurveda. So if you see Ayurvedic tailors, most of the Ayurvedic oils, they use sesame oil as a base oil. It is so good and it is so stable, and that is the reason they prescribe sesame oil. It's very inert or bland and doesn't attribute to any strong flavor or odor, and that's the reason most of the Ayurvedic preparations do use sesame oil as a base oil. So this is again a seed oil, fixed oil obtained by expression or from the cultivated varieties of sesame. We have it, we've been using it in our culinary, and this belongs to the Pedelaceae family. Now it grows abundantly in India, China, Japan and in US. Now this is an annual plant. You will see it fruiting post the monsoon, bearing pods, and in this pods you will see stack of seeds or stack of sesame seeds. On an average this plant grows to an height of about a meter, and if you take sesame seeds, they are nice, they are smooth, flat, oval, whitish. In some cases they might be little yellowish to reddish brown, and if you consume them they have a slight oily taste. The odor is fairly light or bland. How do you prepare it? Again, sesame seeds, we want them intact, they are very tiny. So those pods bearing sesame seeds are threshed to separate the sesame seeds. The sesame seeds are graded. We want the white ones. If you take the brown ones, the quality of the oil goes down. So what we'll do is we'll grade the oil. Now you can press it as such with a mechanical press, but it is said that if you cook or if you steam this seeds, the oil content or the efficiency of extraction improves. Now one limitation is, if you overcook it, the seeds tend to become very soft and slimy and obstruct the extraction process. So you need to be very wise, and they are carefully cooked with minimal amount of steam. Post that they are expressed in a mechanical press. Now this contains a lot of free fatty acids. So once the oil is expressed, it is allowed to separate properly. Once it's separated properly, this is treated with alkali to neutralize the free fatty acids. If at all any pigments are there, they are subjected to bleaching, or sometimes they are just passed through charcoal columns or cartridges to get a purified product. They are hydrogenated partially and discolored completely. So this gives you a good quality, pristine, a little pale yellow, nice bland sesame oil. Now sesame oil, if you see, contains again triglycerides, chiefly of oleic, linoleic, palmitic, stearic, arachidic acids. Now if you see oleic, linoleic, they all C18, stearic, palmitic is C16. You can see your arachidic, you can see your hexadecanoic, lignoceric, which is very big, almost C24, that is 24 carbon, and myristic acid. All of this triglycerides make it bland, make it stable, and you will see their majority of them go in the saturated or mono unsaturated range. So that's the reason Ayurveda treats this oil to be very stable. Now in addition to that, this oil is found to contain an interesting set of compounds. We call them as lignans. Now lignans are C6C3 compounds. So how do you put them is, let us take an example of a commonly occurring lignan. This is your sesamin. So it's a very symmetric, nice molecule. I put it down, and then if you remember how we do it for phenylpropanoids, I am just numbering it. Okay, so 1, 2, 3, 4, 5, 6. So you have your 6 and then 1, 2, 3. So this is your C6C3. Again, I can just put it like 1, 2, 3, 4, 5, 6, C6, and again 1, 2, 3. So lignans are basically dimers of C6C3, which are there in nature, and some of these lignans have estrogen like activity, and they are also known as phytoestrogens. So sometimes, when you consume excessive sesame seeds, they are attributed to estrogenic activity because they act like a phytoestrogen. So the common lignans which occur in your sesame oil are your sesamin and sesamolin, with a little difference. If you can see, it's an ether out here, whereas which is not there in this. Now this might hydrolyze to give you an all, and this all we call it as sesamol. Okay, so sesamolin hydrolyzes to give you sesamol, and you might have sesamolinol also. So these are used for their lignan like saving effect. Apart from that, it contains very trace minute quantities of vitamin A, vitamin E, which are oil soluble vitamins. You can evaluate a genuine sesame oil by checking the lignan and the lignan derivative, that is your sesamolin and sesamol. What you need to do is just take the oil and just take half the amount of, if you are taking 2 ml oil, take 1 ml of concentrated hydrochloric acid containing about 1% sucrose. If you are getting a pink color, that means it has your sesamol. This is what is called as Badoin's test. We also have a Villavecchia test. It is very similar, but instead of sucrose, what we use here is a furfural. So these tests are widely used. They check for the presence of sesamolin and free sesamol, and then can tell us whether your sample is genuine sesame or not. Applications, like I said, it's traditionally used in Ayurveda because the oil is very inert. It's used as demulcent, nutritive and emollient. It's traditionally used for dysentery and urinary complications. Being an oil, it is used as a solvent for steroids, lipophilic antibiotics, lipophilic drugs, certain steroidal hormones, and it is also used in manufacturing of margarine, some cosmetics where it can form an oleaginous base. It is used as a emulsion for your antacids and ointments. It is also, if you see the sesamolin component, that has insecticide property and is often known to exhibit synergistic, or what you call it as enhanced activity when given with pyrethrum. The last oil or the last example what we go, it is a very humble plant called coconut, and from that you get what is called as coconut oil. So coconut oil, if you see coconut, you see a whitish color inner endosperm layer. We call it as copra, and this, when you dry it, when it is sufficiently dehydrated, it's very rich in oil. So initially it might just contain like 30% oil, but when you dehydrate or when you get those dry copras, they contain almost as high as 70% oil. So this coconut oil is the oil which is expressed from the endosperms of coconut, that is Cocos nucifera, which is the Palmae family member, and it grows on all the islands, tropical islands and tropical countries you will find them. And it's cultivated chiefly in Asia and Africa for the same reason. The plant is very unique, so you can see the plant as a typical palm, that is a single trunked appearance with a very big leaves as big as 10 to 20 feet, having numerous pinnate arrange or pinnately compound leaves, almost 200 of them sometimes, and they have a typical spiral arrangement towards the apex of the trunk. That's where you're finding them mostly populated or crowded. Now what is done is the coconut is dried and it is expressed sometimes by heat, and then you allow it to settle. Once it is settled, you take the oil layer and that is then treated, bleached if required, and used as coconut oil. The good part of coconut oil, why it is so important, is it contains a very small carbon chain fatty acids. Like others we have seen so far are C16, C18, C24 and so on. When you see coconut, you can see here it is C8, caprylic acid, C10, capric acid, or C12, lauric acid. So short chain fatty acids, the advantage of short chain fatty acids is they can easily be absorbed by us. So, and the next thing about this is they are all saturated fatty acids. The reason your coconut oil solidifies in winter is their short chain fatty acids have a very ordered appearance, and as a result they have a very nice, what is called as a melting point of 23 degrees Celsius for the whole oil put together. Now coconut, if you see the oil, or what you call it as butter, is nicely white or pearl white, unctuous, odorless, and it has a slight nutty, or what you call it as coconut odor. Now it is soluble in twice the volumes of alcohol when heated, but in terms of its solubility, it is more soluble in organic solvents. Now this oil is unique because it has the highest saponification value. Saponification value is how much amount of KOH is required for the fatty acids. So because it has small fatty acids, it requires more of KOH per gram, and that's why this is an oil which requires, or which has a very high saponification number. And because it contains saturated fatty acid, it is one of the oil with a very low iodine value, that is just 7 to 10. So a unique oil with a very high saponification value and a very low iodine value. Where do you apply it? Coconut oil is again used as base in creams. It's used excellent hair oil. In India we use it throughout as hair oil. We use it in cooking. Now if you see the pharmaceutical industry or the cosmetic industry, you have triglycerides prepared of caprylic and caproic acid. We call it as caprylic capric triglyceride, or CCTG, which is a clear odorless liquid. It is synthetically prepared initially by purifying and then joining it to the glycerol molecule, but it has an excellent emollient conditioning agent and it's abundantly used in your skincare industry. Now another part is what is called as fractionated coconut oil. This is done by carefully melting, solidifying, melting, solidifying and fractionating the coconut oil depending upon its boiling, or what is called as depending upon its melting point or congealing point, and you get different fractions depending upon the solidification point. So this fractionated coconut oil is also used as medium chain triglycerides, and they are also good applications in your pharmaceutical industry. Now, your coconut oil being something which is oleaginous and easily absorbable by gut, it is used in disease associated with malabsorption of fat such as cystic fibrosis or enteritis, or sometimes even your steatoria, which is when your fats are being excreted, not absorbed at all. In that case, you need to switch to low molecular weight fatty acid substitute, and your coconut oil is an excellent resource. So for further reading, here are few references, and thank you for your patient listening.